In this video, we'll be looking at 3.5.2. We're going to talk about long-term behavior of a Markov chain. In the last video, we linked Markov chains and the probability that it comes with to just multiplying probability vector with p. So in this section, we'll use the method of section 3.3.4 to compute powers p of n of diagonalizable matrices, and we'll use it to study the behavior of Markov chain after many iterations. All right, so example 3.5.3, consider once again the problem of example 3.5.2 with the following transition matrix found in example 3.5.2. All right, so this is the transition matrix that we're looking at. That's the one that we found in the conservative versus liberal question. So diagonalize P. So that means find a diagonal matrix D in an invertible matrix R. Yes, so here there's a bit of a clash of notation. It's classical to use P for the Markov chains, and it's also classical to use P for the change of basis, but we're going to use R here just to make sure we don't get crazy things like P equals PDP inverse. All right, so I'm going to diagonalize it. That means I'm going to first find the characteristic polynomial. Again, a slight problem here. So 0.85 minus x, 0.1, 0.15, 0.9 minus x. Right, so I'm going to multiply it. Actually, there's a trick here that I like to use. We know that the sum of the entries is 1. And so if I take the sum of all the rows, something nice happens. I'm going to get 1 minus x, 1 minus x, 0.15, 0.9 minus x. And so I'm going to be able to factor, and that's going to happen for all Markov chains. I'm going to be able to factor 1 minus x out of the determinant. And so I'll already have part of my factorization done. That's especially helpful for bigger matrices. All right, so I get 1 minus x and then 0.9 minus x minus 0.15. And so I get 1 minus x and 0.75 minus x. So I have two eigenvalues. I have 1 and I have 0.75. All right, so we need to find a basis of eigenvectors. So let's check the first one. At 1, I will get 0.15, 0.1, 0.15. Sorry, there's a minus here and minus 0.1. And when I reduce this, I'm going to get 1 minus 2/3, 0, 0. And so I'm going to take a free variable here. X is 2/3 s, y is s. And so I'm going to get my first vector. Let's not call it p. It's a bit too many p's here. I'm going to take s equals 3, so I'll get 2, 3. If I look at lambda is 0.75, then I'm going to get 0.1, 0.1, 0.15, 0.15, and so that one will reduce to 1, 1, 0, 0. I'm still going to have the second variable free, so x is minus s, y is s. So here any s would do. I would take 1. And so let's use R for the matrix just to avoid craziness. So I'm going to get a matrix R 2/3 minus 1, 1. And let's find R inverse since we're going to need it anyway. So R inverse is 2 plus 3 is 1/5. Then I switch to diagonal entries and that's not a minus. All right, and I put a minus in front of the non-diagonal entries. And then the diagonal matrix will have 1 and 0.75. All right, so we've done this part. P is equal to R d r inverse. All right, we're going to use this to compute powers of it. All right, given that a voter has chosen the Liberals in this election, what are the odds that they will vote Liberal in an election? All right, so we're not going to calculate the odds in 2 and 3 and 4. We're going to calculate the odds at any point. So I'm going to need to get p to the n. So we know that p to the n will be r d to the n r minus 1. And so p to the n will be 2 minus 1, 3, 1. D to the n, that 1 stays there, but I'm going to take 0.75 to the n. And then I'll have the 1 over 5, 1, 1 minus 3, 2. All right, so I'm going to multiply this. That way I'll have p to the n, and then I'll multiply it by whatever state vector I'm starting with, and I'm going to get the probability of being conservative or liberals in an election. All right, let me pull the 1 over 5 up front. I'm going to multiply these two first, let's say. So I get 2, and then here I get minus 0.75n. Then I get 3, and I get 0.75n. And so that's 1 over n. Then I'm going to multiply these like this. That's 2 plus 3, 0.75 n. Then 2 minus 2, 0.75 to the n. Then 3 minus 3, 0.75 to the n. And 3 plus 2, 0.75 n. Excellent. All right, let's reread the question. Given that a voter has chosen the Liberal this election, that means we know x0 is liberal, so that means 1 and 0. And so xn will be p to the n x0. And so that means p to the n is 1 over 5, 2 plus 3, 0.75 to the n, 3 minus 3, 0.75 to the n, 2 minus 2, 0.75 to the n, 3 plus 2, 0.75 to the n. And then I'm going to multiply it by 1, 0. I'm going to get the first column. And so I get 1/5. 2 plus 3, 0.75 to the n. 3 minus 3, 0.75 to the n. All right, so this is the probability of voting liberal. This is the probability of voting conservative. What is the question? That they will vote liberal. So probability that in an election will get liberal, that's 1 on 5, 2 plus 3, 0.75 to the end. Compare your answer to what you got in B. Oh, in B is the other one. Let's do 2 elections. So I want to plug in n equals 2. Oh, wait. No, I'm going to plug in n equals 2. So P of xn x2 equal liberal. That's 1/5. 2 plus 3, 0.75 squared. And compute it. Let's compute it together. Get your calculators out. All right, so we said 3 times 0.75 squared. So that's plus 1, plus 1, plus 1, plus 2. So we get 3.6875 divided by 5. And that's 73.75%. Does that match? Yep, 73.75% liberal. All right, so we have all the answers at once. We have a nicer way of computing it. And then what we'll do afterwards is really impossible unless you do this. All right, so I want to find Q, which is the limit of the PNs. All right, so PN is here. Let me cut it. There's no way I will remember it. All right, so from B, P to the N is this. All right, so I want to compute the limit of it. Note that 0.75 to the n, since this interior is less than 1, that is going to 0. So that's 1 over 5. So we'll get 1 over 5. All of these terms are going to 0. And we'll get 2, 3, 2, 3. That's it. That's simple. All right, so find Q, which is the limit of the xn for any initial vector state x0. What does it tell you about votors? So let's see. I'm going to pretend like x0 is a 1 minus a. The sum has to be 1, so let's put 1 minus a. Oops. And so I want the limit as n goes to positive infinity of p to the n x to the n, or x to the 0, sorry. We've actually computed it here for 1, but let's just compute it for all. So I can actually take out the constant like you would do with a regular limit. So x to the 0 doesn't actually gets involved in the limit. And so I'll get 1/5, 2233 times a 1 minus a. And so I'm getting 1/5, 2a plus 2, 1 minus a, 3a plus 3, 1 minus a. And if I simplify the interior, I get 1/5, 2, 3. So that means 2/5, 3/5. All right, so wherever I start, I will end up with 40% probability in the liberal camp and 60% in the conservative camp. So what does it tell you about voter? As a 40% chance of voting liberals and a 60% chance of voting conservative in a faraway election, right? The further away, the better, a faraway election. All right, so I found my Q right here. One thing I want to check is that if I multiply that Q by P, I'm going to get Q again. All right, so what was Q is 2/5, 3/5. What was Q? What was P? P was far, far from us. 0.85.1. Okay. And then you fill it up knowing that the columns add up to 1. So I get 0.85 times 2/5 plus 0.1 times 3/5. Then I get 0.15 times 2/5 plus 0.9 times 3/5. All right, so what do I get? So 0.85 times 2 divided by 5 plus 0.1 times 3 divided by 5. And I get 0.4, and so the other one will be 0.6. That is 2/5, 3/5. All right, so in the next theorem and next definition and next video, we'll be making this long-term behavior clearer. We'll tell you what to expect, what you'll get, what this matrix Q will look like, what is special about this little Q here. All right, so we'll do that in the next video.